So I'm saying from the previous topic, the measure of central tendency, it gives you an hint about how your data is going to be distributed. Because having the mean, you can understand where your data is going to be clustered. Having your mode, you're going to understand where your data is going to be clustered as well as the median. So today we are talking about the measures of dispersion. The first thing is to understand what is dispersion. Dispersion is the main thing that we need to understand. And why should we discuss about it? So, from the English dictionary, that is the Cambridge and the Oxford dictionary, dispersion means variation. So, when we talk about measure of dispersion in statistics, we are trying to understand how our data varies or deviates away from the measures of central tendency. So, we are trying to understand, in short, how a given data set deviates, or sometimes we can say variates away from the measures central tendency. And talk about the mode, median, and the mean. So we are trying to understand how our data is going to deviate away from these measures of central tendency. So here we are talking about, okay, hope you can see my screen at your end. So when we talk about the measures of central tendency, we have what we refer to as the range. We have what we refer to as the interquartile range, semi-interquartile range or quartile deviation. Then we have the coefficient of quartile deviation, the mean deviation, the standard deviation, the variance, and coefficient of variation. These are simple things, and I think most of us, we have covered these things before. But it is like we are doing a reminder for ourselves. So I don't want to take much of your time today. I want by 10 we be through with our class by the end of that time, by 10. So when we talk about the range a small hint is given by, the range is the difference. It's the difference between the largest value and the smallest value. So it is the largest value in a given data set. Then you are subtracting the smallest value. The largest value, then you subtract the smallest value. In other books, you're going to find R is equal to H minus L. So this in short means that you are taking the highest value, you subtract the lowest value. You take the highest value, you subtract the lowest value. That is for what we refer to as range. Then we have what we refer to as interquartile range. So for range, it is mostly calculated. Range is mostly calculated for ungrouped data. Hope at this time everybody understands what we refer to as ungrouped data. So when we have ungrouped data, we normally calculate the range. We take the highest value, we subtract the smallest value. Let me show you an example in the next. Like this, we are talking about the range. It's defined as the difference between the largest score in the data set and the smallest score in that data set. XL minus XS, meaning the largest value minus the smallest. So we are assuming we are given this given data set 48166293969. Then we are asked to find the largest value. In this case, we have the largest value to be, assuming that we have the numbers, we arrange them in ascending order. We have 1, 2, 3, 4, 6, 6, 6, 8, 9, 9. So the largest score in this case is going to be 9, and the smallest is going to be 1. So when you're asked to find the range, you're going to find 9 minus 1, and that one gives us a 8. Up to there, anybody with a question about range? Because I'm not trying back to come back. Anybody with a question? And Frida, Sepas, Gift, Judy, Mercy, anybody with a question? Okay, thank you. So sometimes you can be given two different, I'm not trying to discuss about when to use the range. Those are things about the theory part about, and I'm not doing the theory part. So we have, you can have different data sets, but they have the different range, because range we are taking the highest number minus the smallest. So sometimes you can see, for example, in this case, we have two different data sets. We have 1, 1, 1, 1, and 9, and then we have 1, 3, 5, 7, and 9. And we said the range is the largest value subtract the smallest. So in this case, we have 9 as the largest and the smallest as 1. And in this, the other data set 1, 3, 5, 7, and 9, we have the largest value as 9 and the smallest as 1. So when you get the difference, it's going to be 8 for both cases. So that one may bring about the limitations about range. However, I'm not discussing the theory part about this topic. I'm like focusing on the mathematical aspect. But during your free time, you can go through the theory part. Then we have what we refer to as the interquartile range. We have what we refer to as the interquartile range. So it goes for the interquartile range is for the middle halves of the values. So this is whereby in most books you're going to find it gives us the interquartile range. Let me give the formula first. Interquartile range is going to be equal to Q3 minus Q1. This is the formula you're going to meet in many books. Assuming that up to this point, wherever we are, we understand how to go about the median. Remembering how we went about the median, we were doing in symbol terms, the median for ungrouped data, assuming it is ungrouped data, the median we were finding it as n plus 1, n plus 1 divided by 2 for the case of ungrouped data. So when we talk about Q3 for ungrouped data, Q3 we mean we are looking at the 3 quarters. We are checking the 3 quarters of data set. When we talk about Q3, we mean the 3/4 of the data set. So Q3 for our case is going to be given by the same formula for the median, n plus 1. But here we multiply, because we are talking about 3/4, we're going to have 3 into n plus 1, and we divide by 4, because we are talking about 3/4. The median is all about a half. So for Q3, we are going to have, it is 3/4 of the data set we have above. And in most cases, we are going to find it is the 75th percentile. For those who went and followed the simple instruction I had said, go and read about the percentiles and the quartiles. So it is the 75th percentile, because 75 divided by 100 is going to give us 3/4. It's going to give us 3/4. Then the case of Q1 in this case is the first quarter. It's the first quarter, the data set. It is the 75th, it is the 25th, 25th percentile. And for wherever we are given ungrouped data, Q1 is going to be given by n plus 1 divided by 4. So this is the case where we are given ungrouped data. But we are going to find cases where we have been given grouped data. So let us talk about grouped data. In the cases where we have been given grouped data, sometimes it is so challenging, but assuming that still we remember the formula for the median, we're going to find it being given by L1 as have a bracket, n divided by 2, we are subtracting the cumulative frequency of the preceding class. Then we have h, the class width, and across the bracket, then we are going to divide by the f, the frequency of that class. Having to make you remember again, because this is the last time I'm going to do this, L1 is the lower class limit of the median class. Then we talk about n, the number of observations. Then we have CF, is the cumulative frequency of the preceding class. Then we have H being the class width. Then we have F being the frequency of the median class. So somebody is going to ask you to come up with Q3. Q3 is the 75th percentile, or the 3/4 of the information you have. So it is the 75th percentile still. All the 3/4 of the data set. when you're asked to come up with Q3, you use the formula for the median. Q3, we use the formula for the median, which is going to be given by L1. And we are going to add, instead of now having n over 2, we're going to have 3n. We're going to have 3n divided by 4. Then we are subtracting CF, close the bracket, then we have H, then we have H, then we have our F. So it is the same formula. The only place what we are manipulating, what we are just manipulating is where we had n over 2. We are only manipulating where we had n over 2 to include 3 over 4. Then we talk about Q1, going to be given by L1. Then we are adding, still engage our bracket. Then we have, instead of now having 3 over 4, we are going to have a quarter. N times 1 is n. It's going to be n divided by 4. Subtract CF. Then we multiply H, cross the bracket, then we have F. So still the terminology is maintained. N is the number of observations. L1 is the lower class boundary for Q1 class. Then we have, so entirely, wherever you are asked to find Q3, Q1, median, the first thing you're supposed to find is the cumulative frequency of the data you have been given. So let us move forward, hoping that you're going to find the formulas indicated. So wherever we talk about the interquartile range, we have to find the quartiles. And the quartiles, we have the 3 quartiles. We have Q1, Q2, and Q3. So in most cases, this is called the 25th percentile. Q1 is the 25th percentile. We have Q2. This is the median, also the 50th percentile. Then we have Q3. This is 3/4 of the information, the 75th quartiles. So we do not need to worry about Q2 because it is just the median. Hope we are together to that point. Are we together? Are we together, guys? So when we are talking about Q2, because sometimes if somebody can challenge you, tell me about the 50th percentile of this information, or tell me about Q2 of this information. Always remember that person only wants you to come up with the median. So we should not be worried about the median. We should be worried about Q3 and Q1. So Q1 is simply the middle value of the bottom half. So the bottom half, we are meaning the middle value between the bottom half, which is the 50th value, and below. So the bottom half, we are going to find Q1, while Q3 is the middle value for the top half. So between 50 and 100. So it is 50 plus 100, 150, then divide by 2, that is the 75. And the bottom half is 0 plus 50 divided by 2, and we are going to have our value as 25. Let us proceed. Let's go ahead. So for example, we have been given this kind of data. This is the kind of data we have. It ranges from 10 to 90. The data ranges from 10 to 90. So let us try to find these values. We have, they are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we are talking about 18 values at this point. And now somebody is asking you to find the value, for example, the lower quartile or the Q1, and we said it is n plus 1 divided by 4. N plus 1 divided by 4. So we have n is 18. N is 18, and 18 plus 1 is 19. 19 divided by 4, it is 4 point something. It's going to be 4 point something. So when you get a 4 point something, okay, I don't want to use the formula this guy applied that you divide the data into halves. I want to use the normal formula that is Q1 going to be given by n plus 1 divided by 4. So our n is 18. So 18 plus 1 divided by 4, what is the answer from your side? 19 divided by 4. 4.75. So because we don't have a 4.75, we just count up to the fourth number, then the fifth value is going to give us what we want. So we are going to count 1, 2, 3, 4. Okay, I'm sorry, I just disappeared. I had some technical itch, but we were talking before I disappeared. I was saying about using the formula, Q1 is given by n plus 1 divided by 4. So when we divide n plus 1, note that it's n plus 1. So when we talked about n plus 1, we talked about 18 plus 1 divided by 4, and we realized it's 4.75. That gives us almost, when we go through the values we have, it is going to give us almost the fifth value of the data we have. Then when you talk about Q3 is going to be given by 3 into n plus 1 divided by 4. So in this case, we are going to have 3 times 19 divided by 4. 3 times 19 divided by 4. Who got the value? I said 3 times 19 divided by 4. 3 multiply 19 divided by 4. So it is 14.25. 14.25 is the rower. So we are going to have 1, 2, 3, 4, 5. Our 50 value for 4.75 is 49. Then we have 6, 7, 8, 9, 10, 11, 12, 13, 14. 14.25, you try to round off, it is 14. So it's going to be 62 for Q3. So our Q3 is going to be 62. And our Q1 is going to be 49. So somebody is going to ask you to come up with the interquartile range. The interquartile range is given by Q3 minus Q1, and that is 62 minus 49. It gives you the interquartile range 13. Somebody wants to ask me why 14.25, why we did not go ahead, and why did we go for 4.75? Why did we choose the 50 value? I know somebody has that question in mind, but this is what normally happens. Whenever you have been given a data set and you realize that you can discover the values from whatever you have, it is not a 0.5. Wherever it is a 0.5, it is when you had the two values. But when it is past that 0.5, that time you are supposed to truncate, or sometimes you round off. But in most cases, you are supposed to round off. Anybody with a question before I move to the next op we have for group data? But I'm going to challenge you still. We're using group data because this is a group data they are trying to give us. So wherever, okay, let's talk about the semi-quartile range. They're talking about the semi-quartile range. Semi-interquartile range, not quartile, semi-interquartile range. And in other books, you're going to find quartile deviations. So in this case, it is just the mid. It is given a symbol. This very symbol, QD, Q dot D, that is quartile deviation, is given by half into bracket Q3 bracket Q3 minus Q1. Then you divide, you don't divide, it is half already. So it is given by half of Q3 minus Q1. So that gives us what we refer to as the quartile deviations. Quartile deviations. All the same interquartile range. All the same interquartile range. Then somebody is going to ask you to come up with the coefficient of interquartile range. Is a coefficient of the interquartile range. It is given the coefficient. Let me give it initials. The coefficient of interquartile range is going to be given by Q3, going to be given by Q3 minus Q1. Then you divide by Q3 plus Q1. So that is the coefficient of interquartile range. Is given by Q3 minus Q1. That is the interquartile range divided by the sum of the Q3 and Q1. So the quartile deviation is same as semi-interquartile range. Q3 minus Q1 you divide by 2. And the first quartile is the 25th percentile. Hope you can see now. And the third quartile is the 75th percentile. So still I insist, go and read about percentiles and quartiles, because they will be so key for us to understand. Although I said some notes about the percentiles, deciles, as well as I think there were percentiles there. I shared with you the notes. That's why I don't want to cover much of the time today. I want you to go through the notes. So then we talk about the coefficient of quartile deviation. The coefficient is given as this Q3 minus Q1 divided by Q3 plus Q1. What I had already given you, Q3 minus Q1 divided by Q3 plus Q1. So this is the 75th percentile minus the 25th percentile divided by the 75th percentile plus the 25th percentile. And mind you, wherever you're going to calculate this, there is a note. This is like an int. This will always be less than 1 and will be positive as Q3 is greater than Q1. It is going to be less than 1 and always positive. So whenever you calculate the coefficient of quartile deviation and you realize that you are getting an answer that is not positive and less than 1, then you are doing the wrong thing. So this is a key point to note. Wherever you're going to be given a challenge about the quartile deviations and you are asked to find the coefficient of quartile deviations, then you are realizing that your answer is greater than 1 or your answer is negative, you should question yourself. So that is a hint to note. So we are supposed to talk about next, we are supposed to be talking about variance and standard deviation. Variance and the standard deviation. I'm not going to talk about the mean deviation because it is not important, but I'm going to give a talk about it. So wherever you are asked to find the mean deviation or the median deviation or the mode deviation, number one, what you have, the data set you have already been given, you are supposed to seek to find the mean. If it is about the mean deviation, you look for the mean. Then what you are going to find as the mean, you take all the values. If they are ungrouped data, you subtract the mean from the values. Let me show you what I mean. So we're talking about the mean deviations. The mean deviations. So this D, the D we have here, is our value of X. Let us assume what we have, like, I'm assuming we have data like 1, 2, 3, 4, and 5. This is the data we have. Somebody to give me the mean for that data. And the mean for the data above. Guys, I want the mean for the data above. Hello. We have many people in this class and they are not participating. Immaculate, Dennis, Gift. There are so many people. So I can see a 2.5. There's a 3. So wherever you have been asked to find the mean, we are going to sum up. 1 plus 2, that is 3. 3 plus 3, that is 6. 6 plus 4, that is 10. 10 plus 5, that is 15. 15 divided by the number of observations, we have 5 observations. The mean is 3. Gift, the answer is 3. So when we are informed that our mean equals to 3. So what we do, what we normally do when you are asked to find the mean deviation in that case, because we are looking for the mean deviation, we are going to add. The first value we had was 1. We take 1, we subtract our mean, that is 3. And we are going to add the second value, that was 2. We subtract the mean, that was 3. Then we take the next value. The next value was 3. We take 3, we subtract our mean of 3. Then we have our next value, that was 4. was 4, you will subtract 3 because 3 is our mean. Then we are adding the next value that was 5, subtract 3. So because we are looking for the mean deviation, everything we have, we divide by the number of observations. Our number of observations was 5. So who got the answer? Because 1 minus 3 is -2. -2 minus -1 is going to be -3. This is 0. 0 plus -3 plus 1 is -2. And this is 2. Becomes 0. 0 divided by 5. What's our calculator? 0 divided by 5. 0 divided by 5. Somebody with a calculator, 0 divided by 5. So that's why I did not want to go about the mean deviations. The mean deviation will always be 0, no matter what. Wherever you are asked to find the mean deviations, the mean deviations are going to be always to be 0. So during our next class, this is where we will be starting, because we'll be having the moments about the mean. The moments about the mean, we will be discussing this in our next class. So mind you, you have to remember that the mean deviations will always fall to 0. So during our next class, that's where we are going to start from. Because I told you business statistics is a build-up course. It's a build-up course. Whatever we learn today will be so important for tomorrow's class. So always try to be at par. I don't want to talk about the median deviations and the mode deviations, because somebody cannot come on board to ask you about these things. But for during the next class, remember that we are going to talk about the mean deviations, the moments about the mean. So that one, let me forget about it for now. Let us go back and talk about the variance, the standard deviation. Wherever you have been given any type of data and you have been asked to find the variance or the standard deviation, number 1, step 1, if the data is ungrouped data, or if the data is grouped, the first step you are supposed to go and find what we refer to as the mean. And if it is the case of grouped, you are supposed to find the midpoint first. So those are so important things that you have to recall always. So, for example, let us assume the data we had above, the data we had 1, 2, 3, 4, and 5. This is our data set, and we realize that our mean is equal to 3. Our mean was equal to 3. So somebody can ask us to come up with what? Somebody can ask us to come with the variance of the data above. So the variance for this data above is going to be given by sum, let me use the word sum, of x minus mean. Then we are going to square these, squared. Somebody is going to tell me that this formula is not understandable. Then we are dividing by the number of observations, n. So we are talking about x. This x stands for our 1, 2, 3, 4, and 5. Then this means that we square it. We're going to square it. Then we are going to divide the entire thing by n. So in that case, we can have, for example, because the mean deviations we found it is 0, that's why I'm squaring it at this point. So assume that we have been asked to come up with the variance, and the variance is indicated with a symbol we call sigma. We're going to see that from my video presentation. So when you're told to find out the variance for the data above, we are going to have a big bracket, then we have a small bracket. We have 1 minus 3. That one, we square it. Then we are going to add 2 minus 3. That one, we square it. Then we are going to add 3 minus 3. That one, we square it. And we are adding 2 bracket 4 minus 3. We cross the bracket, we square it. We are adding 5 minus 3. We square it. Then we cross the entire bracket. Then we divide by the number of observations, 5. So when we are continue finding the variance, in this case, the variance is going to be given by, it's going to be 1, no, negative 2 raised per 2. So we are talking about negative 2 raised per 2. Then we are adding negative 1 raised per 2. And we are adding 0 raised per 2. Then we are adding 1 raised per 2. Then we are adding 2 raised by 2. Then we are dividing by 5. 2 raised by 2, the variance, 2 raised by 2, negative 2 raised by 2, negative 2 times negative 2, that is going to give us a 4. Then we are adding 1 times 1, negative 1, that's 1. Plus 0 times 0 is 0. Plus 1 times 1 is 1. Plus 2 times 2 is 4. So that one we divide by 5. So by the time we come on board, that is variance is going to be given by, those who have seen, it is going to be given 10 divided by 5, which in our case variance is going to be equal to 2. Are we together up to that point, guys? Tumefika pamoja? Nani hajafika na sisi? Thank you. Okay, thank you for that response. So I want to challenge you again. Let me give you some data sets so that at least I can see what we are together, so that you can calculate the variance. Let me give you 4, 6, 9. Who is this coming morning? Come on. We're almost in the afternoon. So let us use the data above. I've shared some data, 4, 6, 9, 5, and 8. Let us try to find the variance using the data above. I'm giving 3 minutes for that calculation. Let us come up with the variance for the data. I'm also working on it. The variance for that data, 4, 6, 9, 5, and 8. Come on, your answers. And your answers. Am I trying to think out? Okay, but you can. What was your mean? The value of the mean. The value for the mean from your side. So we are trying to find the variance. The variance is going to be given by, we have negative 2.4 squared, negative 2.4 squared, that is 5.76. So we have 5.76. Then we are adding, there is a 6, that is 0.4 squared, that is 0.16. 0.16. Then we are adding 1.96. I'm sorry, there's something I've made a mistake, but it is in order. Then we are adding 6.76. 6.76. Then we are adding to 5.76. Then the entire thing we are dividing by 5. So after adding all these, we got 17.2. Nani ako na calculator tusaidie? So the variance in this case is going to be given by 17.2 divided by 5. And I think the variance in our case, is going to be 3.44. I think that's my suggestion, that's my calculation. Anybody with the same answer? Hey, Brian, you are celebrating. Let's see, I can see you are celebrating at the other end. So I call upon you to be so careful wherever you think such stuff. Are we together, brothers and sisters? Hope we have. So from my video side, I have calculated for group data. So hope you will be able to see that. So let me tell you about the standard deviation. Standard deviation is given by the square root of the variance. So the standard deviation is the square root of the variance. In some books, you are going to find S dot D.
You are currently the only person in this conference.
S dot S dot D. Are you together, guys? Standard deviation is given as the square root of variance. So it is going to be the variance. We raise it to power a half. Variance raised to power a half is like the square root of the variance. Because I don't, from my type side, I cannot see the square root sign. So in the case, for example, what we have calculated here above, we found our variance. Our variance was given as 3.44. That was our variance. Then somebody asks you to come up with the standard deviation. Standard deviation for that you are supposed to take 3.44, then you are going to raise it to power a half. Amepata jibu? No. That's not power a half. And Frida, that's not power a half. I think you used your phone and it was automatically going to give you that wrong answer. But somebody can do this. Who has a calculator? Try this. If you have a calculator, try this. 0.5 log 3.44. Somebody with a calculator? 0.5 log 3.44. Kaka mnisaidie na jibu. Then antilog 0.3. Antilog 0.3. Antilog of 0.3. Somebody with a calculator to help us with an antilog of 0.3. Faith, Grace, tusaidie. Najua Mangera yuko na calculator lakini hawezi akatusaidia. He's not willing to help. Brian, you don't have a calculator? Antilog of 0.3. Let me Google online to find the antilog of 0.3 if you are not going to help me. So it gives almost the same answer. It gives almost the same answer. I guess it should be almost the same answer. It should be. So I don't have a calculator, I cannot do that. So assuming that you are giving me the correct answers, but I have a variation, what somebody is giving me 1.85, somebody 1.99. Let me assume. Somebody has given a 2. Let me assume because I don't have a calculator. So that's how you go about standard deviation. Standard deviation is the square root of the variance. Standard deviation is the square root of the variance. Standard deviation is the square root of the variance. Then lastly, what we are supposed to understand is the coefficient of variation. The coefficient of variation, in some books we are going to find CV. In short, it's called CV. So when you go about it, coefficient of variation is given by standard deviation divided by the mean, then we multiply by 100%. It is normally given in percentage form. So for example, in our case, we realized that our mean was 6.4 using the data above. Our mean was 6.4 and our standard deviation I'm assuming 1.854 as our standard deviation. So when you are told upon to find the coefficient of variation, the coefficient of variation will be given by our standard deviation is 1.854. We divide it by whatever we have, our mean is 6.4. Then we are going to multiply 100. I want to see the answer in percentage form. I'm sorry, it is not 6.6, it is 6.4. Coefficient of variation, because I know somebody is copying from my end, 1.854 divided by 6.4, we multiply 100%. So something like a 29, I don't know, I'm seeing 29, 28. But it is advisable, don't round off your answers. It is advisable that you give your answer in 4, I don't know what we used to call some 4 figures, 4 significant figures. So not necessarily because I saw somebody rounding 1.854 into 2. No. Don't leave your answer in 4 significant figures. So these people who are rounding to 29, I'm coming for your ears. And this person here, Unfrida, it is supposed to be 28.96%. Don't write it just that way. It is in percentage form. We have it is unit of measurement as percentage. It is unit of measurement is percentage. It is unit of measurement is percentage. So I did from this end, I've used ungrouped data, but in my working with the video, I gave using group data. So purely I've tried to cover whatever we are supposed to understand under this topic. We are supposed to be understanding the range, the interquartile range, the semi-interquartile range, or the quartile deviation, the mean deviation, but that is necessarily 0, the variance, the standard deviation, and the coefficient of variation. It is 9:30. It is 9:30. So I call upon you guys. I'm calling upon you